is a logarithm? That's what this video is about. To answer this question, I'm going to give it the following example of an exponential equation. 2 raised to the x equals 8. It's an exponential equation. Sometimes they call it exponential form because the variable is in the exponent. So we can visualize the answer is 3 because 2 times 2 times 2 is 8. 2 raised to the third is 8. So we know the answer is 3. But say that was a 7 or a 6 and we didn't know the answer, but we still like to solve for x. So that's where we invented logarithms, to be able to solve for x. So x is equal to, this is O is the exponent. So we're going to write the word log, and what goes down here is the base. If you look here in this problem, the base is the 2. So I'm going to put the 2 down there. And the only other number that's left is 8. So that goes here. So again, this is the base, and this is the exponent. Those are the 2 values that I want you to notice. So we just came up with a form or an expression or equation that solves a variable in an exponent. It gives you a form to solve with the variable in the exponent, which is what I'm trying to say. So these two are things that are always going to be equivalent, and that's the formula for logs. So if I had something like log BA equals C, just using any letters, this is going to mean, this is the formula, B is the base. If you remember, that was the base, so I'll write the base. The exponent is always the one that's alone, so that guy's the exponent, and it better equal to the only thing that's left, which is the A. So 2 to the x equals 8, that's what this was, so this is B to the C equals A. That's what that means. Again, the B is the base, and the C is the exponent. Okay, I'm going to put a box around that, because that is our formula. Okay, so let's go the other way around. What if I had log base 4 of 16? What is the answer? Well, that means the base is 4. What is the exponent? Because log means what's an exponent, right? We're solving for the exponent where it's equal to 16. So obviously the answer is 2. And you can see this by, if you let this be some unknown, call it x, because we don't know what that is, and then we're going to say, okay, 4 is the base, x is the exponent, that better equal to 16, and you can visualize that the x better equal 2. So we can see that log is 2. By the way, this is called log form, and this is called exponential form. So you can always go back and forth. Log form is on the left of our formula in the box. On the right is exponential form. You can always go back and forth, whatever fits your needs. Okay, so let's do another example. What if I had log base 5 is 1 over 25. Well, this is a little different, a little more complicated because we have a fraction inside. But we can still figure this out because we're going to let this equal to x. And using our formula, getting it in exponential form, we're going to say the base is 5, the exponent is x, equals 1 over 25. Well, we're going to see that that exponent, that variable x, is going to be negative, isn't it? Because 5 to the negative 2 means 1 over 5 squared. In fact, you can change the 25 to 1 over 5 squared, or you can change it to 5 to the negative 2. So you can see that x is going to be negative 2. If you plug in a negative 2, that would be 1 over 5 squared, which is 25. 1 over 25, I should say. So that is that example. Okay, common logs. A common log is base 10. So when you have something of base 10, it's called a common log. So let's do an easy one. Again, what's the answer? We can see it's 2 because this is the base is 10. What's the exponent to 100? The answer is 2. And again, to see that, 10 is the base, x is the exponent, equals 100, and you can clearly see x is 2. When they use base 10, a lot of times the book will just write with no base. That this and this is an equivalent statement. So the answer we know to that base 10, it's 2, because we just found that above. So on your calculator, it only has base 10. So if you plug in 100 and hit log, I bet the answer would be 2. You can see that the calculator does base 10. So if you did an example of something like 45, well, 10 raised to the what power is 45? That's kind of tough, isn't it? But on your calculator, if you plug in log of 45, you're going to get about 1.65. So we're saying that, let's rewrite this, log of 45 equaling x. Let's forget the x. 1.65. We're saying 10, the base is 10, raised to the 1.65 is approximately, because this is really approximately, about 45. And I believe that because 10 raised to the 1 power is 10, 10 raised to the 2 power is 100, so it has to be somewhere between 45, and if you do that in the calculator, you'll see you get about 45. So things without the base mean base 10. So that's what common logs are. Hope that helps.